biofertilizers. As the name suggests, fertilizers made up of biological agents or biological agents acting as fertilizers. So in this, the emphasis is to use microorganisms like what? Not necessarily bacteria, but also algae, and in some cases, fungi. And what do? A, they fix atmospheric nitrogen, and nitrogen is a nutrient. Solubilize phosphorus, because phosphorus in its natural form is not soluble. It solubilize phosphorus. Decompose organic material. So whenever the leaves or the plant dies, it ensures that there is decomposition of the organic matter. So all the three aspects: fixing of atmospheric nitrogen, solubilize phosphorus, decompose the organic matter. All of them, what do? They increase the soil fertility. Yeah, they increase the soil fertility. Let's look at some of the biofertilizers. It would help if you know some of them. Otherwise, try to remember at least few of them. Yeah. So now, when it comes to biofertilizers, especially these microorganisms, there are two types of microorganisms here. One set of microorganisms, let's say let's take the example rhizobium. So I have underlined the word symbiotic bacteria. It is symbiotic. So we all understand symbiotic relationship is a type of mutualism. Mutualism means win-win. The bacteria gets something and the plant gets something. So what does the bacteria get? The bacteria gets a place to stay. It is able to, it's able to get nourishment. And what does the plant get? The plant is getting the nitrogen fixed in its root nodules and therefore helping in its growth. So it's a win-win. Therefore, my point is, when a bacteria or any other microorganism is in a mutually beneficial relationship, it is symbiotic, which we know. We have studied biotic interaction 2 classes before. When the bacteria fixes a nitrogen, yeah, but does not get anything in return, then it is called as a free living nitrogen fixing bacteria. Are you able to see the simple difference? Symbiotic bacteria are those bacteria which do something for the plant and they get something in return, whereas free living bacteria are those which act as a fertilizer for the plant, but they do not get anything. Now, if you please go back to your biotic interaction table, this phenomena where one is benefited, where the plant is benefited, and the bacteria has no impact because the bacteria is not harmed also. No? It is not benefited, no impact. It is called as, if you remember, called as commensalism. Yeah, where one is not harmed and the other is benefited. Okay. So this is one example of symbiotic bacteria and one example of free living bacteria. Now, one example, if you can remember on both, it will help you. Yeah, rhizobium as symbiotic and azobacter as a free living. Now, I mentioned another bacteria, azospirillum biofertilizer. The reason is, the peculiarity of this biofertilizer is, it is applied to the root itself many times. I'm sorry, not applied. It is applied to the seed itself. When they are sowing it, sometimes they cover it with a layer of azospirillum and then they sow the seeds. And when the seed germinates, these bacteria go to the root surface. Yeah, they go to the root surface and they have a very interesting phenomena of supplying growth hormones and vitamins. They do not fix nitrogen. That's one thing I wanted to remember. They do not fix nitrogen, but they supply growth hormones and vitamins. And the process of applying these bacteria, applying or having a coating of these bacteria on the seeds of the crops is called as inoculation. Inoculation. We always say, inoculation, even vaccine, that way is inoculation of foreign dead or weakened microbial microbes. Yeah. So inoculate. So you're inoculating the seed with a bacteria which acts as a biofertilizer. By how? By supplying growth hormones and vitamins after the bacteria reaches the root. Okay, so that is why I just thought, because each of them is different. One is symbiotic, other is free living, but they both of them are nitrogen fixers. Okay. Now here this is also a nitrogen fixer, but it does not form any root nodules as in the case of the above two. But you need to remember that this term called as inoculation benefit. Sometimes you read it in the newspapers also, means in technical articles, inoculation benefits of microorganisms. If the context is plant, this is what it means. If the context is human beings, then you can understand that it is related to vaccines. Blue-green algae, I think we all know this. So blue-green algae, I am just passing by. Azolla biofertilizer, so water fern, suitable for cooler regions. So some point that you may want to remember. This I thought was very unique. Mycorrhizal fungi. Mycorrhizal fungi. The reason why I mentioned this here, that it is somewhat unique in its ability to absorb phosphorus. Because so far we talked about nitrogen. No? See, one, it is fungi. Fungi are generally not, known as biofertilizer. Yeah. In this case, it is biofertilizer with a unique property of being able to dissolve and absorb phosphorus, which through it gets passed on to the plant. We know that like nitrogen, phosphorus is also an important nutrient. So we looked at cropping pattern. Now we looked at biofertilizers.